All right, number 1. 10 pictures are placed, each measuring 4 by 6. So if they're, that is not the right thing. So if I have a 4 by 6, that's 24, and I have 10, so that is a total area of 240. And then, and we're not going to have any overlap. And the poster board is 20 by 17, and 20 by 17 is 1,240, and the difference between these two, is 340, and the difference between these two is 100. Number 2, let n equal the number of sides of a regular polygon. For n is less than or equal to 3 is less than or equal to n, and less than 10, how many values of n result in a regular polygon where the common degree measure of the interior angles is non-integral? First things first, non-integral. In other words, it is a decimal. It is not a counting number, and it's not a whole number. So we're looking for a number that is not a whole number. And right now, you should be thinking about numbers that have really weird rules of division. 7! Excuse me. The easiest way to do this is to know the equation. So we know that the angle, the number of degrees in a polygon is going to be equal to 180 times n minus 2. So in other words, if you have a triangle, 3 minus 2 is 1, 1 times 180 is 180. A rectangle, 4 minus 2 is 2, 2 times 180 is 360. Now, this is how many total degrees there are. But if we want the interior, I'm going to say interior angles, we need to divide this by the number of angles there are. So the number of total degrees, the interior degrees are in a polygon divided by the number of angles will give you how much each angle is, and so that's an n. So we have this equation here, and I'm going to use the distributive property. And so we have 180 n, I'm running out of space, 180 n minus 360 divided by n. And so we need to put this in parentheses, make sure it's all divided when I use my calculator. Now, so what I did from here is I put this equation into my y equals screen. So I typed this in, and this is what I got. Of course, you can barely see it. So if you look over here, you can see I typed in the equation, and the n value, which is off the screen for this one, is 3. So a triangle, a regular triangle, equilateral triangle we'd call it, has degrees of 60. A square has 90. A pentagon has 108. A hexagon has 120. A septagon has, oh, that is non-integral, is it not? Now, if I were to continue this table, would you mind typing in an 8 there? And here's 9. And here, but we can't go over 10, but we'll put 10 in there just for funsies. We see that we all have whole numbers every time. So 7 is the only value, only side length, or polygon side length that gives you a non-integral interior angle measurement. That means we have exactly 1. So